All right. Hopefully, oh yeah, we're showing up there. So we left off last class talking about looking at frequency distributions. Specifically, we were looking at qualitative variables, right? And I think I ended with an example of how we would do it for discrete variables. It's no different, right? Instead of counting up the number of red cars, you would, count up the number of responses you see that are the number one, right? So couple things you should have done for today. Should have got that online quiz done. You should have gotten the first Learn Smart turned in. I'll actually be posting another Learn Smart after class today that I want you to read before we start class on Tuesday. All right, so you got kind of a week to get that done. Once again, some kind of easy points there. I'll also post another online quiz. It'll have a couple questions that look similar to some of the stuff that we'll talk about today. Should be pretty easy as long as we're kind of paying, an ounce of attention. I think you should be able to get those correct, right? So the next week lectures are up there. I forgot the first week. No one actually emailed me, so it might not be an issue. But sometimes, I think specifically with Chromebooks, the PDFs open a little bit weird. So I always kind of put the exact same thing. Sorry, the PDFs. The PowerPoints open kind of weird. So I put up the exact same thing as a PDF version, and it opens, for whatever reason, if this PowerPoint doesn't work with your computer, the PDF, I've never had a problem with people being able to open that up, okay? I also kind of re-uploaded just when I got here, this COVID data blank file, which we'll be working with a little bit today. So that's sitting there in the in-class data folder. So we'll be working with kind of those files as we continue through today. So before we get going, does anybody have any questions or anything? No, we're good? Okay. So we left off thinking about variables that were qualitative, right? So we had this cause of death, right? So this is a qualitative variable. We got the frequencies. We then said, if we have the frequencies, well, every observation or every death here should have been counted in one of these categories. So if I add up all my frequencies, I should get that total number of observations down here, okay? To go from frequencies to percent frequencies, we said all we do is divide that frequency by the total number of observations and then multiply by what? Yeah, right? So once I multiply by 100, that turns my relative frequency, which represents a proportion, into a percentage, right? So now I've got these percent frequencies. I can graph them and kind of put them into a column chart, right? To kind of visually show what that distribution looks like. Now, if I just look at the numbers here, I can see the majority of deaths come from heart disease, right? The highest majority, 32%. Next highest looks like it's cancer, 26, and kind of so on and so forth. But I can put this in a graph, right? So I can't remember, I think last class we just started talking about how we would do this. So here, I grabbed the wrong cable, so we don't have the dot cam today, but we shouldn't have to do a ton of board work. So we'll use this terrible annotate tool in Zoom. I probably shouldn't say that Zoom. People might not like that. So let's say I've got this graph, right? I've got my X and my Y axis. On my X axis, I'm gonna put the different responses I could see, right? So the very first type of death I could see was heart disease. I then, to draw my bar for heart disease, would draw a bar that went up to whatever the frequency was. So here it was like what, 5.5 million, right? So my first bar for this first category, which is the response for that qualitative variable of heart disease, had a frequency of 5.5 million, okay? I then go to my next category. I'm going to shorthand it. It was what, malignant neoplasm, so we'll put cancer here just to kind of make it a little bit easier. We draw a bar for that. It doesn't go quite as high because the value that we're going to use for its y-axis is its frequency, which is only kind of 4.4 million, right? And then we kind of continue to plot the rest of the categories until they're all in that graph, right? So if we did that, we would get something that looks like this, right? Very quick visual. I can see which of these two causes of death are the leading causes of death. I can kind of see the numbers of people that are killing pretty quickly, right? Using the frequencies there on my y-axis, okay? Now, if instead I went through the exact same process of creating that graph, but I used the percent relative frequencies, notice the graph looks no different, right? So this is the same as this, with one exception. Before, my y-axis was frequency, so the count of each type of cause of death. Here I've got the percent relative frequency on my y-axis. So the reason why the graph looks the same is because, if I divide any numbers by the same number, it doesn't change the relative size, right? 5 is half of 10. If I divide both of those by 5, 1 is half of 2, right? So it doesn't matter because I'm multiplying and dividing by the same number. The relative size of each category isn't going to change. The only thing that changes is the number that whoever I'm presenting this to can see on the y-axis. And that's just situational. Sometimes it may, if I'm, I don't know, there's causes for each one of these types of death, and I'm trying to, argue for a higher percent of some funding that might exist out there. Maybe I want to show that my cause of death is the one that has the highest percent. Maybe I'm trying to make somebody care more about a specific cause of death, and so I show them, well, look, it's over 1 million people dying, from this disease, or so on and so forth. So this really just depends on what message you're trying to convey or what you're using that visual depiction of the data for. Right? And I'll show you, I don't think we did it last class, we just had the data. I'll show you how we can create these pretty easily in Excel today. Okay? Oh, we also have pie charts, right, we could create. So you've probably seen these before, right? The larger the slice of the pie, the higher the percent of overall deaths, or if we're talking about in general, the percent of responses of this particular type for whatever variable we're looking at. But in this case, percent of deaths that come from this one specific cause, okay? So that shouldn't be too bad. I think we then kind of started this discussion of, well, what if we have discrete data? And I kind of showed you in Excel, it's no different, right? Instead of counting the number of red cars or the number of deaths that came from heart disease, I'm just going to count the number of times I see 0 in the data, the number of times I see 1 in the data set, right? Because discrete was where we had just these integer values, right? Now, the problem was when we had continuous data, things kind of go, not quite as easily, because if I wanted to treat it the same as I was the other variables, I'd have to count the number of, let's say I'm looking at the variable of income. Okay? I'd have to count the number of people who make $0, write that frequency down. Then count the number of people who make 1 cent, write that number down. 2 cents, write that number down. I'm going to have a graph that's way too long by the time I get to the highest income that someone's earning, right? So it doesn't really make sense to look at every single possible response for a continuous variable. So what we're going to do is create these things called bins or classes. Those two terms are interchangeable. And it's going to be a range of values. And if an observation is within that range, I will count it to belong to that bin. So in the income example, maybe I do something like this. I say, how many people make between 0 and $100,000, right? I go through my data set, I count them up, I write that number down. That's my first bin, and that bin's frequency. I then say, okay, how many people make more than 100,000 up to and equal to $200,000, right? Count up all those observations, write that frequency down. That's the frequency for my next bin. How many people make between 200 and 300,000? So on, and I keep on going until I've counted every single possible income value I could see. Now, that's going to be good. We'll talk about some problems that could occur specifically with that idea of having a data set with a bunch of different people's income in it. So if we were to do this process though and have all these bins with their frequencies, we then plot them just like we did with that heart disease example, right? Kind of use the bins as my x-axis now and the frequencies still as my y-axis. We'll call that kind of column or bar chart a histogram. And all that's saying is, look, I'm showing you the data as though I could only see 5 responses, but these aren't actual responses. This is a range of possible responses, right? My first bin of $0 to $100,000 isn't one response. It's capturing a bunch of different possible values that I could see. So that's all a histogram means. It's still a bar chart, still a column chart. And we're just really letting people know the data started out as continuous and we counted it, kind of into these bins that we created, okay? So usually the number of classes, the number of bins that we select is somewhere between 5 and 20. There's no like hard and fast rule on this. The problem is if I don't choose more than 5, let's say I just say how many people make between, I don't know, 0 and $100,000 and how many people make more than 100,000. That's not a very interesting graph, right? If I have more than 20, well, now I just got this really long table, or sorry, really long graph. It doesn't look very nice. So I want to try to keep it, somewhat small number of bins, but not too few to where the graph really doesn't tell me much about the distribution of the data. Okay. So once we know how many bins we want, how did I decide in my income example that I wanted to look at 0 to 100,000, 100 to 200,000, 200 to 300,000? Well, we're going to have a formula that helps us kind of calculate what the optimal bin length would be, given the data that we have and the number of bins that we want. So how we calculate that optimal bin length, we'll take the maximum value we see in our data set, we'll subtract the minimum value, and then whatever that difference is, divide by the number of bins. And I'll show you an example of this in Excel in just a second. Okay? So this is kind of our bin length formula. This gives us a good idea about what the optimal bin length should be. Okay? So in my example, let's say I use that formula and I came up with 100,000, right? That's why I was going from 0 to 100,000, 100 to 200,000, 200 to 300,000, right? That was my bin length, or I might accidentally use the term bin width. It's the same thing, right? Just kind of what that range of each bin is going to be. So generally, there's 3 other things we have to make sure that we do when we're creating these bins. The first, make sure they're mutually exclusive. These bins or these classes are mutually exclusive. So the biggest, well, I'll give you an example of a really egregious way that this wouldn't happen. So let's say my first 2 bins, I say, are if someone made between 0 and 100,000, and then my second bin, I count the number of people who make between 50 and 150,000. So what's the problem with that? Well, people who make, for example, 75,000 would fit in both those categories. So I'd be counting observations in multiple bins. So we don't want to do that. So the idea of mutually exclusive is that every single value that I could see would only belong to one bin, right? So you might think when I go 0 to 100, 100 to 200,000, 200 to 300,000, then I've solved that problem. We still have to be a little bit careful on kind of those edges of the bin. Because if I say, how many people make between 0 and 100,000, and then the next bin is how many people make between 100 and 200, what's the problem with that? What if I make exactly $100,000? Which bin do I get counted on? So we have to be careful with the equalities. So I might say, how many people make from 0 up to and including $100,000? And then the next bin is, how many people make more than $100,000, right? So the equality is only there on one of those bins. And we'll do an example in Excel on that. It might make that a little more clear, but we want to make sure our bins are mutually exclusive. They have to be exhaustive. So all this means is that if there any value I could see for that variable would be counted in at least one of the bins. The only issue we ever really run into with this, and the income example is a good one. Let's say I do $100,000 bin lengths. So 0 to 100,000, more than 100 to 200,000, more than 200 to 300,000. Keep on going. And let's say I stop at, 2 million. Well, what's the problem? You got people out there like Jeff Bezos who are making way more than that, right? So I might be missing a couple of those high observations. So sometimes when we deal with but I don't want to keep doing $100,000 jumps all the way up to whatever, Bezos is making or Elon Musk is making. So what I'll do is I might make those $100,000 jumps, but then say, how many people make more than $1 million? So that last bin, I'll kind of make this catch-all category, right? And that kind of helps us so we don't have this huge number of bins, but allows us to make sure that it's exhaustive, right? That we're including every possible response we could see. We'd be counting it in at least one of those bins. And then kind of finally, we want to make sure these bins are the same length, right? And every example I've tried to give you, I've been using that convention, right? All my bins in the example I was giving were all $100,000 in length. Right? So we'll go through kind of how we would do this by hand, quick calculating bin length, and then we'll take a look at some of this stuff in Excel, okay? So let's say I've got SAT scores for a bunch of different Indiana high schools. I want 9 bins, and I want to see kind of the distribution of SATs, average SAT scores in these high schools. So the lowest average SAT score in these Indiana high schools, one school had 352, and then the highest, one school had 648, okay? So I've got my minimum and my maximum value that I see in this data set, and I've got the number of bins I want. All I do is plug things into this formula, right? So plug in that maximum, plug in that minimum. I think the number of bins I said we wanted was 9, so plug in 9 down in the denominator. If I do that, I get about 32.8. So this formula is, maybe think about it as it's the optimal bin length in terms of the mathematics or the statistics, but it's not optimal in terms of visual depiction per se, right? If I'm creating bins and the length is 32.888 repeated, all my labels for what that bin range is are going to be kind of messy, right? They're going to have these nasty decimals on them. You know, why 32? Like, you know, maybe even 30 sounds like a nice kind of more round kind of value to stop at. And so this formula in practice is more like a good starting point, right? Now, the mathematics side of it, it tells you the optimal bin length for them all to be the same length, all the bins to be the same length. But really practically, we'll kind of play around with this. It's kind of our starting point. Once we see this value, we say, well, I actually just want to kind of, to make it a little bit nicer visually, I'm just going to use an integer instead of have all these decimals. So I'm going to round this up to the next integer, right? And just use 33 as my bin length. Now, if you ever do this and you're rounding it up, I kind of call it, you have to make sure you ceiling the variable, right? Or you kind of push it up to the next integer. So even if this was 32.1, you'd want to make sure that you actually used 33 as your bin length. Because if you don't, and you use 32, by the time you get to your last bin, it actually won't be quite high enough to include that maximum value in the data set. And so you won't have an exhaustive kind of, your bins won't be exhaustive, right? It won't be counting every single observation. So first use this formula and then kind of push it up to the next integer if you want like a nice cleaner kind of visual. And I'll show you, we could actually go even further than just pushing it up. Is that, okay. Screen just went blank on us. I'll show you how you can do even more than just push it up to the next integer if the situation calls for it, right? So here's a bunch of slides. And this was an older example. The cell references went with a different data set. I kind of updated it for this semester. I want to do something a little bit different. So I'll go back through and I'll update all of these slides after we go through what we go through today. They're really just meant to match up with what we do in Excel, right? So they're kind of like reference slides to go back to. But as long as you're paying attention, you're working through, or you're watching this kind of part of the video where I work through it in Excel, you really don't have to kind of pay a lot of attention to these slides unless you're kind of going back and reviewing, right? So let's go to this COVID data blank file. Let me zoom in so you guys can actually see it. Okay, so got a bunch of different worksheets down here in Excel. The one that we're going to be working with is this state level data worksheet, right? So it's got, well, I think as of last Friday, it has the total number of cases and the total number of deaths in every state in the United States, right? As well as I think, yeah, Puerto Rico and DC, or there's some other, yeah, here it is, DC. Okay. So I'm going to be saying, you know, we're talking about these as though it's the states, but it does include, you know, those two additional, I guess, territories. So the first thing, if we wanted to take this data set, and let's say we're going to use the total number of cases variable, and we want to get a visual depiction about what the distribution looks like in terms of COVID cases across the different states, right? So there are a lot of states that have really small numbers of cases, or there's, you know, a lot of states that have really high numbers. We can get an idea if we can get this visual of the frequency distribution. So before we can even determine, you know, what our bins are going to be, and I kind of cheated here, and actually I forgot, I didn't resave the file. I had a typo here. So I'll type that in, and don't let me forget, I'm going to mention something about that typo later. So let's say I decide that I want to break this down into 6 different bins, right? This kind of is up to me. If you have a homework assignment or anything like that, this will be told you, right? The number of bins that you should be using is going to have to be given to you. But in practice, you choose it, right? So we're just going to decide that we want 6 bins, and we want to kind of get a frequency distribution with these 6 bins. So the first thing we need to do is determine what is our bin length going to be, right? You can kind of see down here, I have what would the bin length be for my bins here. It's pretty easy to tell off the first one. The length is, yeah, right, 525,000. I'm going from 0 to 525,000, and then it's the rest of these, if you calculated it, they're all 525,000 in length as well. Or kind of the range of values is 525,000. How did I get to that point? Well, I was going to use that formula we talked about, which said we need to take the maximum minus the minimum and then divide by the number of bins that we wanted. Right? So how do I find the maximum or the state that has kind of the highest number of COVID cases, right? So we'll tell Excel, put an equal sign in the cell and say, I want you to use a built-in function. That function is the max function. So just equals max, put a parentheses, and then you're just going to select all the numbers that you want to find the maximum of, or essentially look through that variable, which the variable here, the total cases, right? And find the maximum of that variable, right? By looking through all these values. Now you can close the parenthesis here, or if you just hit enter, it should do it for you. Sure enough, it went through all these and it found that what? The highest number of cases here was in California, right? Which makes sense, right? It has a high population. I then could do the minimum, which if maximum, the function is max. To find the minimum, the function in Excel is just min. So equal sign min, parentheses, select the data. Now I can't remember how much I hammered this last class, but there's a little shortcut, especially with larger data sets. I click on that first cell for whatever variable I'm interested in, hold Control Shift or Command Shift on a Mac, hit the down arrow, and it sends me to the very bottom of my observations, selects them all for me. Instead of scrolling back up and like typing in and closing the parenthesis, if we simply hit enter here, it kind of puts that parenthesis on there for me, okay? So now I've got my minimum and I've got my maximum, and I know the number of bins I want. So now I'm going to calculate that optimal bin length, right? So that equation is going to be take the maximum, subtract the minimum, divide by the number of bins. Well, the nice thing about Excel, unlike a calculator, in a calculator I have to type everything in, right? I have to type in 3,085,040, subtract, it's going to take a little bit of time. Here, all I have to do is click on the cell that the number's in. So I want to take the maximum, so it puts that cell reference in for me. I then want to subtract the minimum. I don't know why my laptop and Excel does this sometimes. It doesn't on my desktop. So it's covering the cell, so I can't click on it. But I know that the minimum's in what? I2. So I'll just type that in. So I took the maximum minus the minimum, and then I want to divide by my number of bins. Right? So why is this going to give me the wrong answer? Yeah, right. So just like with a calculator or doing math by hand, we have to be focused on order of operations in Excel, right? So what this would do is divide the minimum by the number of bins, and then whatever that value is, subtract it from the maximum. That's not what we want to do. We want to take the maximum minus the minimum first, so we put that in parentheses, and then we divide by that number of bins. Okay? Any questions up to this point? Before I enter here and see what that optimal bin length is. You guys see this okay in the back? I'm going to blow it up a little bit more. Here, let me go here. Let's try just a little bit more. All right. So I get kind of this messy bin length, right? So mathematically, this is the optimal bin length. This is not a nice visual on my graph, right? So I decided just kind of a nicer kind of round value, whoops, would be 525,000, right? So instead of pushing this up to the next integer, I actually pushed it up to the nearest 25,000 marker. And this is all, if it comes to a homework, you should have a clear idea about what your bin length should be. In practice, you might make decisions like this, right? Where you're trying to choose a value that just looks nice on your graph, right? But would still capture every possible response that you could see for that variable. So we'll call this the bin length. So bin size is kind of the optimal, what the formula is going to give us, and then I'll kind of use this bin length I chose using this as a guide, right? Using that formula as a guide. So what I'm going to do first is say, okay, I actually, not to waste class time, I created the labels for each bin ahead of time, okay? I could have made these labels a little bit better. I'll actually show you an example of some probably more well thought out or kind of spent a little bit more time on making the labels. But here I just have them to identify, here's the range of values for the first bin, here's the range of values for the second bin, so on and so forth, okay? So that first bin, right, is going to start at 0. So the very lowest value in that bin that I could see that would be counted in that bin would be 0. Right? The highest number I could see in that bin is 525,000. Okay? So what I'm going to do here, and this is because I can kind of foreshadow, I can see ahead a little bit where we're going. You might not be able to at this point. Is I'm actually going to use cell references already, okay? I'm going to take the minimum of the bin, right, starting at 0, and I know the maximum, well, it should just be whatever my bin length is. So what I'm actually going to do is add to that 0, right, add to the minimum of the bin, whatever I want that bin length to be, right? That way, even if my first bin didn't start at 0, let's say my first bin started at, I don't know, 10,000. Well, if my bin length is 525,000, then the stop point for that first bin would be 10,000 plus 525,000. Okay? I'm doing this for kind of a sneaky reason here, but hopefully we'll see why in just a second. Okay? Now notice where this bin leaves off is where the next bin will start, right? Now we're going to have to be careful about the equalities. I kind of already mentioned that earlier. But in terms of where the last bin stopped, well, that's where the next bin picks up, right? So here I count the states that have between 0 and up to or equal to 525,000 deaths. The next bin, I'll count the number of states that have more than 525,000. So that 525,000 is kind of my cutoff. So the minimum of the next bin will actually always, and you can kind of see this from the labels, the minimum of this bin is always the maximum from the previous bin. Right? Because that was picking up where the last bin left off. Just enter here. And notice to get the maximum of this bin, well, I would just go, where did this bin start? And I would add to it whatever the bin length is, right? Just like I did before. And I would continue this process for all of the, next 4 bins. But if I don't want to type this in every single time, because that is kind of annoying, I don't want, especially if I didn't have 6 bins, like what if I had like 20? This would get kind of old. Well, based on how I did the cell references, when I copy this down, instead of J7, when I copy this down one, it'll be J8, which is exactly what I would want this to be, right? This bin is going to pick up where the last bin left off. So that cell reference, right, I should be able to just copy down and it will work for each of the following 4 bins. Now the maximum of the bin equation, I8, right, when I copy this down one will become I9. So I will be starting at the minimum of the next bin, so that's good, that's what I want. But here I'm adding I4, when I copy this down one, that cell reference will become what? I5, right, it updates. So I5 has nothing in it. So what do I want to do to this cell reference? We kind of talked about it a little bit last class a couple times, but if I put $ in front of the column and row heading, it freezes that cell reference so it doesn't change, right? So putting $ in front of the row and column heading, we call that like freezing the cell reference, okay? Now when I copy this down, here I'd be using I9, which is what I want to do, and I'd be adding to it that bin length still. So now I've got these set up so that when I copy these down, it gives me the minimum and the maximum of each bin. Notice matching up with kind of the labels, which I basically just did that kind of calculation in my head. Okay. Now, you know, I could do these calculations in my head a little bit easier because I changed this to 525,000. Let me show you what happens. Let's say, we don't worry about this function. I'm not going to expect you to know it. I'm just showing you this as an example. There's a function in Excel where I can, I think it's 0.1. Yeah. So this function that I use basically just pushed it up to the next integer, right? Instead of going all the way up to 525,000. So notice, if I've been using this cell reference for my bin length, all these updated. And I can't do this math in my head, right? Now to make the labels, I'm just going to have to type those out by hand. But, you know, it's kind of nice that if I use cell references, everything automatically updates for me. If instead of using that 525,000 as kind of my bin length, I just simply round up to the next integer. Okay? So we'll go back to the old value though, because this looks a little bit cleaner there. Any questions up to this point? We're okay with all this? Shouldn't be too bad, especially kind of, I don't know, hopefully we're getting a little bit more familiar with Excel. So last class, when we wanted to count the number of red cars that we had in that data set, we used the COUNTIF function. We're now going to use the COUNTIF function again to get frequencies, but instead of COUNTIF, we're going to use the COUNTIFs function. Okay? So this COUNTIFs function does the same kind of thing that the COUNTIF function did. It's just it has two criteria that has to be met. So instead of counting the observations where we see the word red, here we actually want to count the observations if the value is greater than 0 or less than, or sorry, not or, greater than 0 and less than or equal to 525,000. So there's two criteria that we need met. So the very first thing that this COUNTIFs function needs is the range of data you're going to be looking through. So that's this total case variable. So I'll select up here, hit Control Shift or Command Shift on a Mac, hit the down arrow, or I could have just selected it with my mouse, and I've got my range of data now, okay? So the next thing that it needs, and every time we tell Excel a function, if it needs multiple things, we have to separate those with a comma. So the first thing we select is the range of data, comma, what's the first criteria? Well, we need to check to see is it greater than 0, right? So we put that greater than sign in quotation marks, just like last class when we were using the equal sign, we had to put that in quotation marks. That's just the syntax of Excel. We then have to use this and sign because I'm going to use some cell references. I'm not just going to type in, is it greater than 0, right? Or is it, greater than 1,050,000, right? Because then I'm going to have to type it in for every single one of these bins, and there's actually a shortcut I can do so that I only have to type this COUNTIFs function in one time, and then I can copy it down. So we'll say, is it greater than the minimum of this bin? Is it greater than 0? Comma, you would think we could just put the next criteria, but the way this COUNTIFs function works, because it has a couple other uses as well, not just for what we're doing, we actually have to say, okay, go back through the data again, right? So I already told you to go through this range of data and see, count the observation if it's greater than 0. But I want you to go back through those observations and count them only if this second thing is true as well. So we have to select this range of data again. We could use our shortcut. We could select it with our mouse. A lot of the times at this point, what I would do, especially with a larger data set, because notice, if I use that shortcut, it sends me all the way down here, and I got to scroll back up. But I know what that range of data, I know what the cell reference should be. It should be C2 through C53, right? Because I'd already had it selected there. I already had it in that equation once. And kind of that colon kind of is saying go from C2 all the way through up to C53, okay? Then put a comma. So basically, select the range of data, put in your first criteria, select the range of data, comma, put in your second criteria. So the second criteria here is we want to count it if it's greater than 0 and less than or equal to 525,000. So we'll put that less than or equal to sign in quotation marks. Now, the nice thing about Excel in this one particular case is you type things in the way we say them in English, right? Less than or equal to. So we put less than or equal to. If it was greater than or equal to, you would put the greater than sign and then the equal sign. So that's kind of nice. And then we want to say, is it less than or equal to this maximum of the bin, right? 525,000. Let me scroll over so we can see all this on one line. There we go. Okay. So now we should be able to get the number of states that have total COVID cases as of Friday between 0 and 525,000. So I hit enter. 37 of those 52 states and kind of territories have COVID deaths in this range. Okay. Any questions at this point? We're working through this. Yeah. Yeah, so usually if you do get like a value, it's either you selected a cell that didn't have a value in it, like it would be blank, or there's something kind of wrong with the syntax. So, something common in these, make sure that you have these commas in between each thing. Make sure you're using this and sign when we're using the criteria. Make sure that COUNTIFs is spelled right. If you use COUNTIF, it's going to have too many arguments. It might give you that error. Let me think of some other common pitfalls here. Oh, okay. So, any other questions before we keep moving? Okay. All right, so I want to do this for every single bin. I don't want to type this out another 5 times. That was kind of boring enough as it is, right? So once I have this in there once, the next bin, I don't want to use I7 and J7. I want to use the minimum and the maximum of the next bin. Well, that's great, because when I copy this down, I7 and J7 would become I8 and J8, right? Update it or copy it down one row. All the cell references get updated down one row. So perfect, right? I'll copy this down. Everything looks great. There's one problem, right? If I go all the way down here, notice, yeah, it's using the minimum and the maximum of that bin. But look what happened to the range of data. It kept updating once as well. And so now I'm missing these first few observations, okay? So I'm going to go back up here. I want the cell references for the minimum and the maximum of each bin to change, but for that range of data, I don't want that to change. So I'm going to select that range of data. Instead of manually putting in the dollar signs, I think I mentioned this last class as well. I've got quite a few sections that I'm starting to get mixed up, but you would highlight what you want to freeze, put those dollar signs around. And if you are on a Mac, you hit Command T. If you're on like a regular PC, hit F4. And some PCs have an FN key. Usually, mine's in the bottom left corner. I think usually they're up by the escape key, but I could be wrong. So you hold the FN key and hit F4 if you do have an FN key. So F4 or FN F4 if you're on a PC. If you're on a Mac, highlight what you want to put dollar signs around and hit Command T. Okay. And not when I shouldn't say hit. Hold Command T and hold FN F4, right? You don't hit them in sequence. You actually have to hit them at the same time. We also we selected the range of data twice, so we need to freeze it over here as well. So once again, Command T on a Mac, F4, or hold FN and hit F4 if you're on a PC. Okay. So we've got those frozen. Now when we update this, the range of data will stay the same, but my cell references for the minimum and the maximum will get updated for each of the following bins. Copy this down. It's working out okay. Right? Now the numbers didn't change here because it just so happened to be the first few observations were all in that first category. If they hadn't been, all bets would have been off there. I could have had some really screwy numbers. Okay. Any questions on this? Well, now we're at a point where this really, at this point, it's everything we've talked about with qualitative variables or discrete variables. Once we have the frequencies, everything else plays out the exact same way. So one thing I could do in Excel, select my labels. Because my labels and my frequencies aren't right next to each other, I can't just select all this data. I'll select my labels, hold Control, and I don't know if on a Mac, I'm guessing it's probably hold Command. Then select my frequencies, go up to Insert. There's all these graph or these chart options here. You can do 2D, you can do 3D columns. All right, let's do 2D for now. And notice now I've got my labels down here to identify kind of what the range of values are for each one of these bins. And then I've got kind of the frequency in each one of those bins. Right? So just insert, go to that column chart, 2D, 3D, whichever you want. I don't really care. Making a graph pretty is not what this class is about. That's something else. I'm showing you how to get the statistics into that graph or into that visual. Okay. So I want to show you a couple other things here. We could have inserted a pie graph as well. Notice there's a pie graph down here. So kind of makes that nice pie graph. Here are the labels, kind of over my different bins. So that's something we could do. It's easy, once I've got the data selected, it's just inserting a pie graph or inserting a column chart where there's the only difference there. What we could also do is, so let's say I had my frequencies. Right? If I went to insert and I put in a column graph, notice if I didn't select my labels, now my bins are just numbers. I don't know what that means, right? What's the range of values? So let's say I created this chart, I didn't know that I could select the labels and the frequencies at the same time, or I'm having a hard time doing that. If I click on these numbers down here, notice there's now like a box around them, and I right click and go to select data. Here are my horizontal axis labels. Right now they're just numbers. If I click this edit button, oh, hold on. got to move this chart out of the way. All right, let's do that again. So right click, select data, hit the edit button. Now for my, instead of numbers as my labels, I want these to be my labels. So I just select them, hit OK, hit OK. Now I've got those labels on my x-axis. So the easier way is to just highlight them before you insert the graph. But if you had forgotten to, or when we get to some of the other graphs, I think we might get there today. If not, next class for sure. This is how we have to kind of put the labels in for time series graphs as well. Okay, we actually have to go in, edit, or hit the select data button, then go to edit and select wherever our labels are in the Excel sheet. Okay? Any questions on that? Okay with that? Let me check on Zoom. All right. And I'm going to pull this up just so I can give you a, I think I used it in the fall, similar example. Your homework will be a little bit different, so it's fine if I show you this. So these are probably better labels than what I created for our example, just out of the sake of time. But kind of notice here, I put not just, 100 to 125,000. I put, this variable x is greater than or equal to 100,000, but less than 125. Greater than or equal to 125, less than 150, right? And I could probably make these even look better if I made this graph bigger, if I can get them all on the same line, kind of spread out a little bit, right? So, you can spend a lot of time on the labels, and that's probably a good thing to do when you're actually presenting, your data to someone. For the sake of what we're doing, we're just trying to get the data and the labels into a graph. From there, the editing is kind of outside this class, right? All right, so here's our crappy labels for this example and our frequencies, right? So I'm going to move this down here for a second and talk about a few things that we talked about last class, but also kind of applying it to this continuous variable. So first of all, to get the relative frequency, what is all I have to do here? Take the frequency and divide it by, how do I get a relative frequency from a frequency? We said last class and even at the beginning, we just take the frequency and divide it by the total number of observations, right? Well, where's my total number of observations here? I don't have it, but we said if we simply add up all these frequencies, every state or territory should have been counted in one of these bins. So when I add up the frequency of every single bin, they should add up to my total number of observations. So I can use this sum function in Excel, just select my frequencies here, and it will add them all up for me. Oh, why didn't it like that? Equals sum. Oh, there we go. All right, select my frequencies and hit enter. I accidentally selected down one too many cells. That's why it gave me the error message there. So 52. Sounds about right, 50 states plus the additional 2 territories. But let's say I had an example where it wasn't states. I've got, thousands of observations of maybe people and their income. It doesn't start in the very, the data set maybe starts down here like on row 6. So I can't just look at the row headings and get the total number of observations very clearly. One thing I can do, or maybe I don't want to scroll all the way down to see where it ends. There's a function, and here, this will just allow us, if we did everything correctly, these frequencies should add up to the total number of observations. If we made a mistake, it might not. So a good way to check yourself at this point is we have this function, which is just the count function in Excel. All this count function does, you select the range of data, and it counts every cell that just has something in it, basically telling you how many observations you have. So equals count, parenthesis, and then I'm going to select this total case variable. So once again, Command Shift on a Mac, or hold Control Shift and the down arrow on a PC. Instead of scrolling up and closing the parenthesis, nice little shortcut, we can just hit enter, and it does that for us. And sure enough, I've done this correctly. I've got the total number of observations here from adding up my frequencies is equal to the total number of observations in my data set. Okay. I can maybe show you, let me see. I think I have Indiana counties in this data set. So here's a little bit longer of a list. And one thing that's kind of nice, you know, using that count function and using that shortcut, right away, before I even start to do anything, I can get the total number of observations I have, right? So, you know, just kind of an example of the larger data set, but here, same exact process. Okay, so now I've got my total number of observations. I can get my relative frequencies. So I take my frequency, I divide it by that total number of observations down here, and that's all I need to do. Now, if I copy this down for the rest of the following bins, I want K7 to become K8 and then K9 and then K10. But this K13, I don't want it to keep updating, right? I want to keep using that total number of observations as my denominator. So I'm just going to manually put those $signs in to freeze that cell reference, okay? Now when I copy this down, the next cell will divide 11 by 52. The next cell will divide 1 by 52, and so on and so forth, okay? So just to make sure, I don't know if I said this last class, when I'm copying these down, I'm just left clicking. Notice when this little black arrow comes up, might be a little bit hard to see, but it goes from white to black. Left click, and then when you drag down, that's how you copy those cells down, okay? So I've now got my relative frequencies, right? What if I wanted my percent relative frequencies? This one's easy. All I have to do is what? To get percent frequencies, we take take my relative frequency and multiply by 100, right? So that kind of six-sided star, it's our multiplication sign there in Excel, right? That's all I have to do. I can copy this down. Now I've got my percent relative frequencies, okay? So that's pretty easy, I think. If I wanted to graph these, select my labels, hold Control, or I think on a Mac, hold Command, select my percent relative frequencies, go to Insert, not pie graph, I want a column chart, and there I go. I've got my kind of percent frequencies there on my y-axis, and I've got my kind of bins there, sorry. Got my percents on the y-axis, and I got my bins on the x-axis, okay? Any questions on any of that? Go through a few more things here in Excel. If I add up these relative frequencies, what should they add up to? Yeah, someone just held it up, right? They should add up to 1, right? Basically, the relative frequency is telling us the proportion of states that have deaths in this range, the proportion of states that have deaths in this range. And so if I've counted every single state, once I add those proportions up, right, we should have every single thing accounted for, which essentially would be a proportion of 1. Right? We said proportions are between 0 and 1. Right? The highest you could ever have is 100 out of 100, which is 1, right? Proportion of 1. 100 divided by 100 is 1. So if we do that, it's a nice check to make sure that we did this correctly, right? If we add these up and we get relative frequencies are equal to 1, we at least haven't made an egregious error. Same kind of thing with the percent relative frequencies. Those should add up if we use the sum function there. Kind of cheated copying that down. So let's use that sum function. Add up my percent frequencies, right, hit enter. Those should add up to 100, okay? Anything else I want to say here? Let me see, let me check the slides. I think I go into cumulative frequencies. What time we get out of here at 1:45? Okay. I guess we'll tackle that today. Okay. So, before we go to cumulative frequencies, because we haven't really talked about those yet, I want to make sure when it comes to that first Excel assignment, which I'll likely be assigning after class Thursday, depending on kind of how much material we get through on Thursday. This will be kind of what we've done in class. I'll post like all this that we've worked on. I'll post a complete version of this file on Canvas as well under that in-class data folder. So that'll be a good template for a large portion, or at least a little bit more than half of that first Excel assignment. But what I don't want you to do when it says to create a histogram, right? I walked you through all of this for a variety of reasons. One reason, right? Because we need to become more familiar with Excel, right? And so I want you to get used to using these count ifs functions. I want you to get used to using some of these other count if, or the max, or the sum, right? Because we're going to need those down the road. And this is a good time for us to kind of start applying them and start learning them, right? So when you do this, if you just type in a number on your Excel assignment, if you just type in 37 because you counted it up by hand, that's not going to get full credit, right? I need to see these functions that are doing it, right? The whole reason we're doing it in Excel is to use these functions in Excel, to use the power of Excel, not just do it by hand and type the number in Excel, right? What I also don't want you to do, so I walked you through to kind of learn those additional functions, but also this gives us a lot of freedom, right? In terms of not being locked in to like a built-in tool, sometimes has default options or has options you can't change. So this allows me to really manipulate and kind of play around with those bin lengths. It allows me, if I use these cell references, even if my bin length changes a little bit, so let's say I do, I don't know, 530,000, it'll update things automatically. Let's say I do something kind of crazy. Notice when I update it, it'll update my frequencies. So, right, that's another kind of useful, another pro of this approach. What I don't want you to do is select this variable of total cases, go up here to insert, and there's now an option in Excel that says statistics chart, histogram, right? So notice it'll create a histogram for you, but it's got these really kind of not very nice numbers. You have to go into the options, like let's specify the number of bins you want. You have to go into the options and, you know, decide where the equalities are. And it's a lot, you know, it's supposed to be user-friendly, but honestly, it's a lot harder to work with than this. And if you want things to change, you got to go back through and change all these different options. Here, using cell references, right, we make a change to that bin length and it automatically updates everything for us, right? Okay. Any questions on that before we move on? So don't use that built-in tool when it comes to the homework, okay? All right. So let's work on this cumulative relative frequency, okay? So the idea of cumulative, right, go back here. So we had kind of these frequency distributions or even relative frequency distributions if we use relative frequencies as our y-axis. The screen comes back on. Okay. Relative frequencies on my y-axis. What if I wanted cumulative, right? So the idea is, we won't talk about these because I'm not going to make you do these, but you could basically, I'll mention this, sorry, briefly. I forgot about this. It doesn't matter. So instead of a column chart, you could have inserted a line graph, and it basically shows you the same thing. It just kind of connects each one of those bins with a line as opposed to kind of using individual rectangles. Really displays the same information. What I do want to talk about is this idea of cumulative frequencies, right? So the graph, I don't know, the book says they're called ogives. I've never heard that. Really, I've always heard them called like cumulative frequency polygons, okay? So what we're going to do with cumulative frequencies, the best analogy I have is like your GPA. Cumulative GPAs are what? It accounts for every single grade from this current semester that ended all the way back to when you were a freshman. Your current GPA is just this semester. So cumulative frequencies, right? A regular frequency is just the frequency of this bin we're looking at. Excuse me, cumulative frequencies are the frequency of this bin plus the frequency of every bin below that or before that, if we want to kind of make that analogy to GPAs. Okay? So here would be kind of a nice graph. We'll eventually get this in Excel. But I think the easiest way, since we've been working in Excel, to kind of use Excel to explain this idea of cumulative, right? So if a cumulative relative frequency is the frequency of the current bin you're looking at plus every bin's frequency below it, right? Well, we've got the bins ordered here. The very first bin, if the cumulative frequency is the frequency of that bin plus every bin below it, the cumulative frequency of relative frequency of this first bin would just be what? It's the frequency of the current bin plus every bin below it. How many bins are below this? 0. There's none, right? There's nothing that exists. So for that very first bin, the cumulative frequency is just its relative frequency because there's nothing else below it, right? So we'll then go down, oops, I'll hit enter, and then I'll go down here. For the second bin, the second highest bin, it'll be the relative frequency of that bin plus the relative frequency of every bin below it. Well, there's one bin below it, so I'll add its relative frequency in. Okay? Well, what about the third one? So I'll go take its relative frequency and add to it the frequency of each bin below it. Right? And I kind of keep walking through this process all the way down to the very last bin. Well, that's kind of tedious. I'm gonna have to keep typing this in and selecting the cells, and if I had 20 bins, it's gonna take me a while. But there is a shortcut we can use here, right? And another way, actually, to see this, let's just say I do cumulative frequencies and not relative frequencies. It's the same idea, right? For that very first bin, the cumulative frequency is the same as the relative, or it's just original frequency, because there's no bin below it to add to it, right? And I go down here, and I would say take this frequency and add the frequencies below it. What I could do is say, well, look, when I add in that frequency from the bin below this current bin, so I'm going to take this bin's frequency and add to it the frequency of the bin before it, well, that frequency would just be the cumulative frequency for that bin as well, right? So if I use what? I should be able to click on it here, but it keeps going away on me. So cell reference N7 there. I'll be taking the current bin's frequency and adding in, right, the bin below it, right, the cumulative frequency from the bin before it, right? Kind of copy this down. We actually get the cumulative frequency to update automatically, because by the time we get down here, I'm taking this bin's frequency and adding it to the cumulative frequency for the bin before it, but that cumulative frequency, right, represents the sum of every frequency below this, right? So that's kind of a shortcut that we can use. And so instead of typing it in like this, right, I could just say, take the cumulative relative frequency from the bin before the current bin I'm looking at, and add to that the relative frequency of this current bin I'm looking at. Okay? If I do that, now when I copy this down, it'll update for every single bin and have the correct thing, right? So here, take this frequency, add it to the cumulative frequency of the bin before it. So let me try to give you a better visual of exactly why that occurs. So let's say, this actually might be good, so side by side, right? So on this left-hand side, right, we'll kind of keep it pretty easy here. So let's say I've got my relative frequencies. I don't know, this one, let's say, is 11. This one, I don't know, let's say it's 7, right? And then we'll do one more category. We'll say this one has a frequency of 3. Okay? So my very first bin has a frequency of 11. My second bin has a frequency of 7. This third bin has a frequency of 3. So these are just like not cumulative. These are the kind of our regular histograms that we'd be looking at. If and I could go through and just label these as kind of bin 1, bin 2, and bin 3, right? They'll have a range of values, but we're not concerned with that for right now. So if I think about the cumulative frequency for that first bin, well, it's just going to be it's just going to be the frequency for that bin plus every bin below it, but there isn't a bin below it. So when we start to draw out the cumulative frequency over here on this graph, for the very first bin, right, that's pretty easy. It's just going to be its own frequency of 11, because there's no bins below it. Well, what about for that second bin? Right? Well, its cumulative frequency over here on the right-hand side will be bin 2's frequency plus the frequency of every bin below it. So 7 plus the frequency of the bin below it, which is 11. So we'd be at, here, probably going to run out of room here, but 18, right? That frequency of 7 plus the frequency of the bin below it. So 7 plus 11, 18. Okay. Once we get to that third bin, right, it's going to be the frequency of that third bin, which is 3, plus the frequency of every bin below that. So 3 plus 7 plus 11, right? So 3 plus 7 plus 11 is what? 21. But notice, if I would have taken the frequency of this bin and added to it the cumulative frequency of the bin right below it, 3 plus 18 is also 21, right? Because the cumulative frequency of the bin below it really just represented the sum of all the frequencies from this bin all the way to the left, right? Or all the way down to the lowest value. So, you know, just different ways of kind of thinking about this cumulative relative frequency. And that's why the way that I had kind of typed it into Excel so that we could copy it down, really that idea was that you take the frequency of the bin you're looking at, so bin 3, its frequency is 3, and I add to that the cumulative frequency of the bin right below it, so that cumulative frequency was 18, and that's kind of what we copied down in Excel, and that's why it worked. Okay? So with this idea in mind, what should, oh, I gotta turn this off. So is everybody okay with this if I get rid of this real quick? Okay, all right. So let's go here, back to the Excel file. Notice for my cumulative frequency, as I go to higher and higher bins, by the time I get to the last bin, what should my cumulative frequency always be equal to? If my bins are completely exhaustive, I've counted every observation once, by the time I get to that highest bin, the cumulative frequency should just be not 1, that the cumulative relative frequency should be 1, right? Because I should have counted every single observation, 100% of the data, or a proportion of 1. But my frequencies, cumulative frequencies, should just be equal to the total number of observations. So notice here, by the time we get to the last bin, my cumulative frequency is the total number of observations, and my cumulative relative frequency is 1, right? So those are gonna, hopefully, you know, if we've done this and we get to that last bin, if those numbers aren't the total number of observations and the, you know, and it isn't 1, we made a mistake somewhere. Okay. If you want to see any of that again, want me to click on a cell, show you the formula, or any other questions on that? Yeah. Say that again. How do I get the total? Yeah, so the cumulative frequency, I was saying, should always, once we get to that last bin, the cumulative frequency should always be the total number of observations, right? Because by the time I get to that last bin, I've gotten to the highest value, I should have counted every single observation. So when we get to that cumulative frequency to that last bin, it should always be equal to the total number of observations. And the cumulative relative frequency for that last bin should always be 1, because we should have counted every single observation. Any other questions? All right. So, you know, once I have those cumulative frequencies, if I can get my mouse to work here, what's happening? Oh no. All right, once we have those cumulative relative frequencies, you know, we could select the labels, hold control, select my cumulative relative frequencies, go to insert. Instead of a column chart, let's do just a line graph. That's typically how we kind of show these cumulative frequencies. And we're done, right? So this won't match up with the slides perfectly because it was using a different data set, but I'll get all those updated so that we see exactly what we would have if we would have created that in Excel. Okay. Well, I guess we did here, but. So that's pretty easy, nothing really new there. Talk about a couple other graphs to end the class here today. The first being a scatter plot. So up to this point, we've really just been looking at one variable, and we've been graphing like the distribution for one variable. So another graph we can do pretty easily in Excel, and maybe Thursday, we might not get there until Tuesday. We'll start talking about different statistics we can use to measure the relationship between two variables, right, as opposed to one. So a quick and easy way we can get a visual of this is using a scatter plot, right? So a scatter plot basically takes two variables, treats one as your x-axis, one as your y-axis values, and plots every single data point that you have, right? So, whoops. if I have this data set, which has health expenditures per capita and life expectancy for all these different countries, I might want to know, well, what's the relationship between these two variables? As countries spend more on their healthcare, not healthcare, just general health, does their life expectancy go up? You would think maybe it does, right? You want to know, maybe, is there a positive relationship between how much money people spend on their health and how long they live, right? So all I did is I copied, whoops, we'll come back to that. I copied this data set, and it's in here. I know the screen just went blank, so I'll wait. It's in that Excel worksheet as life expectancy scatter plot. So once you have your X and Y values, actually, we'll select the labels up here as well. You just select those two variables, go to Insert. Kind of notice this one looks like a scatter plot. It's just got dots on it. Go to Insert Scatter. And now we have every single data point plotted on this graph. And this is where I'm sure, like in maybe other classes in high school, or even maybe at the collegiate level, once you have this scatter plot, you start to think about things like lines of best fit, right? What line would best fit this data? Looks like it might be like a upward sloping line, or there's this positive relationship. As countries spend more on their health, looks like maybe there's a slight increase in their life expectancy. Although it doesn't look like a super strong relationship, because we got, you know, this guy over here, you know, this is the country spending the most on their health, and their life expectancy of these OECD countries is, right, second lowest, right? So maybe it's not a perfect relationship, but it gives us a quick kind of view of it, right? And that was as easy as highlighting the data, the two variables, and inserting a scatter plot there, okay? A little bit more interesting just from that data set. So here is that scatter plot. I made the bubble. You can play around with some of the visuals. You can make the dots bigger or different colors. So if we look at this, interestingly enough, that point is actually the United States. If we look through the data here, they have the highest expenditures, but the second lowest life expectancy, right? So, you know, what's the takeaway from this? I don't know, maybe our health expenditures are just too high. We're not actually getting a lot more like high quality health. We're just spending more money on it, right? Maybe it's just become more expensive due to, you know, however our system is set up. You can look at, you know, other countries as well. Poland was the one that was kind of the outlier here. Japan has the highest life expectancy. You know, but the scatter plot gives us a quick idea about what that relationship is between those two variables, okay? Let's say we had the unemployment rate in the US. This was my time series example I gave you back last Tuesday. So once again, all I did was I copy and pasted this into this COVID data blank workbook. It's the very last worksheet. So here's that data. Simply, right? So I'll show you kind of the only issue with time series graph. If I highlight both the year, right, that's kind of, I would think, oh, it'll use these as my labels, right? My x-axis will just be years, and then my y-axis will be where the unemployment rate was, okay? So I highlight the data, I go to insert, and I'm going to say, I'm just going to do a line graph. Oh, what's going on here, right? Well, it treated the year as another variable. So it plotted like two variables on this graph. That's not what I wanted. So I'm going to delete this, right? I just want this unemployment rate to be plotted on that y-axis. So I'm just going to select the variable that I want to create a time series graph for. I'm going to go to insert this line graph. And now I get this nice kind of time series graph. Okay? Now what I can do is if I click here and then right click, right? So left click the numbers, you get this box around them. Let me zoom in here a little bit. Right click on that box that goes around the numbers, go to select data. Our x-axis, we don't want just to be 1 through whatever. We actually want to use the years, right? We want to be able to identify the years that were plotted. So we just highlight these years, hit OK, hit OK. Now we've got this time series graph where we've got the unemployment rate from 2005 to 2020. Okay? So why these time series graphs are so helpful and so useful is I can basically look at this and tell you a story, right? I can say in 2005, unemployment was around 5%. it dipped in the mid 2000s before making a pretty sharp jump in the late 2000s, peaking at around 2010. It then slowly declined up into 2019 and spiked incredibly in 2020. I'm sure we can take a guess why unemployment spiked in the US in 2020, right? So, just from this nice one graph, I can tell you kind of what's happened to the unemployment in the US over this stretch of time, right? And one thing that might even be more useful, I'm going to make some numbers up here. So this might be, this might look like kind of a mess, but just for the sake of showing you this example, let's say, I don't know, I had Canada's unemployment rate here as well. I could actually highlight both the US and Canada's unemployment rates, insert that line graph, and they'll plot both of those countries there. Now, if I had selected the labels, right, so instead of just selecting the data, let's call this United States, let's call this Canada. If I select the kind of name of those variables I'm plotting, and then I also select the data, now when I insert that line graph, it kind of uses the labels here, identifies them by color. Okay. Now I still have to go in and edit, select the data and hit edit and select the years to get my x-axis to have the correct labels. But it's really not a whole lot more difficult to get multiple kind of countries up there or multiple variables up there on a time series graph. Okay. Any questions over any of that? I know I went through that a little bit quick there, especially adding in Canada. I don't know what its actual unemployment rates are. I'm guessing it probably mirrors the US, but so I kind of have a little bit of a summary of how we do that. You can watch the video again. I think that's pretty easy. Here's a graph that we created. We'll start next class talking about distributional shapes. We'll then move to measures of central tendency like the mean, and hopefully by the end of class relate these distribution shapes to these measures of central tendency and why we call certain distribution shapes what we do, okay? I will post an online quiz as soon as I get back to my office. I have it ready to go. It'll be due before we meet on Thursday, so 12:30 on Thursday. It's due before then. It's 2 questions. We're paying attention today. They should be really, really, really easy questions. I'll post the next Learn Smart up there that I want you to read before class on Tuesday. So you have a whole week to do that, get the easy points. Other than that, if you have any questions, feel free to email me. Next class, I'll bring this sheet that just has boxes, and I'll have you guys write your name in at the end of class as we're leaving, just to kind of get an idea about where you're sitting every class and try to kind of sit in the same place just in case we have to do some contact tracing throughout the semester. But we'll do that Thursday as well. Okay? All right. Have a good day, and we'll see you on Thursday.